From the outside, drones look almost magical, hovering in place, gliding forward, and correcting themselves even in windy conditions. But behind that smooth flight lies a hidden system of physics, sensors, and algorithms working together at lightning speed. So what's really happening every second that keeps a drone stable in the air? Let's break down the science of stable drone flight. This isn't just about spinning propellers, it's about balance, feedback, and technology that mimics some of the smartest tricks found in nature. A drone generates lift by pushing air downward with its propellers. According to Newton's third law, the air pushes back, creating the upward force that holds the drone in the air. But here's the challenge. If one motor spins even slightly faster than the others, the drone tilts and drifts. That's why stability starts with perfectly balanced thrust between multiple rotors, arranged in opposing directions to cancel out unwanted spinning. Inside the drone, a tiny computer called the flight controller is constantly reading data. Accelerometers measure changes in motion, gyroscopes detect rotation, magnetometers sense direction, and barometers track altitude. Paired with GPS or even visual cameras, these sensors form a complete picture of the drone's position in 3D space. Raw data isn't enough. The real magic comes from a control system called PID, proportional, integral, derivative. Think of it like the reflexes of the drone. If the drone tilts left, the controller instantly increases thrust on one side and decreases it on the other. If it drifts upward, the system cuts back just enough power to keep it level. These micro-adjustments happen hundreds of times every second, far faster than human reaction time. Even the shape and weight distribution of a drone play a role. A symmetrical design, a low center of gravity, and lightweight materials all help the drone stay naturally balanced before the software even begins to correct it. Interestingly, researchers are now looking at birds like the kestrel, which can hover in strong winds by adjusting their wing shape. Inspired by this, engineers are developing drones with flexible, morphing wings that could remain stable in even harsher conditions while using less energy. The future of drone stability may look less like a machine and more like a bird. So the next time you see a drone floating effortlessly, remember, it isn't magic. It's the perfect mix of physics, engineering, and nature's inspiration, working invisibly to keep it steady in the air. That's how drones achieve stability, one tiny correction at a time.